right, so what I'd like you to do is go through this investigation. So start by, maybe I should help you for the first part. Okay, how do we multiply fractions? You just multiply. What does that mean? You're thinking of addition. We just go straight across. Right? We multiply straight across. Crazy. Okay, 3 times 1. That's good. 3. And 4 times 2. 8. All right. So what I'd like you to do is try the same thing with the next one. Try so with fractions, we multiply straight across. So I want you to multiply these two together. X plus 3 over 2 times x plus 1 over 4. Never know. Okay, how do we multiply? What do we have on the numerator over here? What's this called? It has 2 terms. No, if it has 2 terms, what is it? Binomial. So when we go straight across, we're multiplying a binomial with a binomial. Jesse, we just said it. What do we have to use? Distributive law or FOIL. Okay, so how do we do that? Start with the first. X times x, x squared. Now what do we multiply next? X and 1. Good. X times 1. X times 1. 1x. Now what do we multiply? Now we do the 3. So we first distribute the x into both, right? It's a binomial. It's like a double distributive law. Now the 3 into both. So 3 times x, 3x, and 3 times 1, 3. On the bottom, can we go straight to multiplying those two? 2 times 4, 8. Okay. So is there anything else we can do? Combine like terms. Very good. Always be, as long as we kept that same order and it was in that order here. Yeah. So it says describe a process you could follow to find the product in simplest form when multiplying rational expressions. So let's just explain what we just did here. When we multiply fractions, how do we multiply fractions? What do we do even just if you explained this to somebody in your own words? How would you explain that to somebody in your own words? So you, expand top with top, bottom. What are you doing with the top and the top? Multiplying. Good. So multiply numerator with numerator. Numerators. Or numerator with numerator. And multiply denominators with denominators. Then after we do that, we're going to simplify. Very good. Now in all of this, what do we have to remember to do? Also, always with rational expressions. There's always like this extra piece that we tend to forget about. So we always have to simplify and also state and PVs. And we always state them before things cancel out, right? So we're comparing it to the original relation. Now here's a little trick with fractions that we talked about last day, and I want to kind of talk about it as well. we can actually simplify before we multiply. So we can do the simplification last, or we can actually simplify ahead of time. This is really cool about multiplication and division, or we talked about this last day. You can do it in any order, as long as we just have multiplication and division. There's no other operations. So if you had, let's say, 2 over 5 times 10 over, I don't know, 14. It could be reduced, but oh well. So there's two ways we can solve this. What's one of the ways that we just did? We went straight across. I kind of answered that for you. Another way, do you remember we covered this on the first lesson? Can we pre-simplify? What can we simplify here? The 2 and the 14. What can we divide both of those by? 2. So this becomes a 1 and a 7. 10 and 5. We can divide both of those by 5. So 1 and 2. And then can we go straight across? Yeah. 1 times 2. 2. 1 times 7. 7. And a lot of times that's nice because if we make numbers smaller before we make it bigger, it's a lot easier. We can do mental math, right? Simplifying 20 over, that would be, I know this, 70, might be a little bit hard. Well, 2 over 7, that would be easy. But sometimes, right, it's not always that easy. And so the same thing can apply when we have something like 2 times x plus 3 all over 5 times, let's mix it up again, 4 times x plus 3 all over 5x. Okay, so instead of going straight to multiplication, you can also simplify first. What can be simplified here? The x plus 3's can reduce to 1. Yeah, what else? We can divide both of these by 5. And so now, let's move, oh, that's ugly. Let's move it over. There we go. Oh. Now let's go straight across. So what are we left with on the numerator? 2 times 1 times 1 times x, or 2x. And then 1 times 4 times 1. Right, we have a 1 here times a 4 times a 1 is 4. In fact, could we have reduced more? Yeah, we can divide both of those by 2, x over 2. So we could have even done that. And if you have to simplify, sometimes you might not notice that, and then you can do it later. And then state your restrictions. X can't be equal to what? Always go before cancellation. Look at our denominators, -3. So let's go back. So explain why is it important to identify all non-permissible values before simplifying when using rational expressions. So why do we have to state NPVs before cancellation? So we can find all of them? Because sometimes what happens to our NPVs? Sometimes they cancel out, and so it's almost like they're hidden. We're really simplifying the original expression. So everything's based on the original expression. So sometimes they cancel out. But they're still valid. We still have to state that because everything's based on the original. The original is what we're simplifying. Okie dokie. Let's multiply. Okay. So the strategies when you multiply and divide rational numbers can be used to multiply and divide rational expressions. So if a, b, c, and d are polynomials, then. So when we have multiplication, let's highlight this. Notice how we go straight across, and we have to find our restrictions for b and d, right? B and d can't be equal to 0 because we can't divide by 0. We're going to talk about this a little bit more in depth, but notice we'll get to division again right away, but when we divide, remember we multiply by the reciprocal. Remember we did that on the first day when we did some review? Notice how there's 3 different places we have to find restrictions for now. For B, C, and D when we divide. Why might that be? And we'll talk about it more again, but still let's talk about it now a little bit. Why would you have not just C? Why is there both that are important? Do you want to take a guess? Well, let's look at this, okay? Let's try. We know that we can't divide by 0. So what if we had, say, 1/2 divided by, let's first look at D, 1 over 0. Is that possible to do? No, it's not. Like, is that even a number? No, this doesn't even exist. It's not even possible. We can't divide by 0. It's not even something. It does not exist. Okay, so there's that case. Now when we divide, what if we had 1/2 divided by 0 over 1? When we divide, what do? Flip and, so flip the fraction, reflipical, I like to call it, the reflipical, and switch, flip and switch. Can you do that? No, because now we just created a number that doesn't even exist. We can't divide by 0. So because of that flipping, you can't have a 0 on the numerator or the denominator on the second expression. And so there's 3 places we're going to have to look for NPVs when we divide. Okay, moving on. Here's the thing, with all of this unit, our first step is always going to be wanting to factor, because we're going to always want to simplify. Always we're trying to simplify here, whether we're multiplying, dividing, or even solving for x. So that first step of factoring, both the numerators and the denominators. Identify NPVs, right? We do that before cancellation. Multiply numerators with numerators, denominators with denominators. Simplify using common factors, then write the product, state the restrictions. Okay, so lots of words. Let's actually do that. A, can you do A on your own? And then maybe if you're feeling brave, B. Without your calculators, if possible. Don't just type it in. Once you've done A, try B. Don't forget to state NPVs. Okay, I'm going to show you 2 ways to solve these, both of these. Somebody want to come up and do one of them? Okay, Jesse, here you go. Do you need to take your book or no? Just in case, it's kind of like a safety net. You do whatever you want to do. Okay, so you divided the 5 and 15 by 5 and the 4 and 8 by 4. 1 over 6. So that's one way we reduce ahead of time. So he divided both 5 and 15 by 5 and 8 and 4 by 4. Did a lot of you do that? Yeah, did anyone use a different method? No? Okay, what did you do, Kayla? Times them across and then reduce. Okay, so you got 5 times 4 is 20 over 120. We can divide both of those by 20. Yeah, or if you only notice 10, then you get 2 over 12, and reduce that to 1 over 6. Okay, so both would be fine, right? Multiply straight across, then reduce, or reduce, then multiply. So let's look at this guy. Did anyone multiply straight across first? No? Anybody? Okay, let's do that one. And then the other method. So straight across, I would have 4x squared y. And, oh, y squared, thank you. 3xy times 8x, what would that be? 24 x squared y. When you have the same bases being multiplied, we add the powers. Then we can reduce. So 4 and 24, what can you divide both those by? 4. So 124 divided by 4? 6. What happens with our x squareds? Cancel. And then a y squared divided by a y. Just a y where? On top. So y over 6. What's our restrictions? Go back to the original. X and y both can't be 0. So far, so good? Now, a bunch of you probably simplified ahead of time, but you might find that easier. Does somebody want to come up and do that if they simplified ahead of time? Anyone brave enough? Should I call somebody up? No, you don't like it? I like shaking your head no. Okay, let's do this together then. What can I reduce right off the bat? Okay, the 4 and the x's. Yeah, let's do the 4 first. We can divide both these by 4, which gives you 1 and 2. What else? The x's. I have x squared here. This 1x. What else? The other x. We have an x here and an x here. You can reduce those. Anything else? It gets kind of messy if you use this method. One of the y's. So we're going to be left with 1 y on the numerator. So then I have 1 times y. Y. 3 times 2 times 1. These are 1s too. Right, these are all 1s. Gives us 6. And state our restrictions. X and y can't be 0. Okay, next page. Lion. Okay, let's mix it up. So those were both monomials divided by monomials. Excuse me. Let's throw in some binomials to the mix. So what was that first step? Factor. What can we factor here? The numerator here, we can divide both of those. Andrew says by 2x. I'm going to change these to dots instead of the time symbol, because then you don't accidentally confuse them with x. Let's figure out what's in the brackets. 2x squared divided by 2x. Remember we talked last day, you might want to write divided by 2x because you're factoring it out. That's going to help you. So 2x squared divided by 2x, just an x, minus sign. 12x divided by 2x, 6. Hey. I always get excited when I see something like that, right? Why? Cancel who? Yeah, tell me one of the things we can cancel. You're right. X minus 6, right? These are the same. You might want to add the invisi brackets there. It might make you feel more comfortable, right? By identical binomials with each other we can reduce. Now that it's in factored form. Anything else we can reduce? 15x and 5. and 5x. What can we divide both of those by? Let's do the 5 and 15 first. Divide both by 5. So 15 divided by 5, 3. The x's, can we divide both those by x? Can't reduce those out. Just 1 and 1. Okay, so what are we left with on the numerator? 2 times x times 1 times 1 times 1. 2 x over 3. Restrictions. Go back to before cancellation. 6. And what's another one? X can't be 6 and Stacy? X can't be? There's another MPV. But we always look before cancellation. We're always looking for what variable? Or for a variable, right? X or a y or something on the denominator. Is there another place where there's a variable on the denominator? How about this one? Right, so if it's a monomial, it'd be x can't be equal to 0. All right, I'd like you to try the next one on your own. Now again, if you like, you can multiply straight across and then reduce. You're welcome to do that. Start by factoring, right? I need you to get these done too. Okay. So rewrite it out with this over this times this over this. Mm-hmm. Mm-hmm. All right. I'm going to show you two ways. Do one way and then the other. So most of you got this far by factoring out the 3x here. Oops. Times, you factor out the 4x squared here. Okay. Now, if you notice right away, okay, those binomials cancel. If you get stuck here, like there's x's everywhere and numbers everywhere, you can start by multiplying straight across and then reduce. You don't have to reduce everything if you feel like you can't keep track of everything, right? We can still multiply across. 12 times 4 is 48. Okay. X cubed times x squared, x to the 5th, and then I have a 3x and then times a 5. 15x, and then reduce. So if you feel like there's so much canceling going on you can't keep track, right? Just multiply straight across, then reduce. We can reduce part of it. We could even still have the x plus 2's here if you wanted to, and then reduce. So moving on, 48 divided by 15, what can we divide both of those by? 3? Yeah? Okay, what's 48 divided by 3? I'm going to grab a calculator. What is it, Jesse? Okay, 16. And divide this by 3 is 5. And then x to the 5th divided by x, what's that going to leave us with? X to the 4 on the numerator. Where do we look for our MPVs? Before cancellation. So what are my MPVs? Let's call in Ashley. What's one of my MPVs? Just one of them. -2. X can't be -2. And the other one, Raina? 0. Right. So the monomial here would be 0. Okay. Now, even at this point, before cancellation, you could have multiplied straight across. Right? It'd be identical here, just we'd have x plus 2 in brackets and x plus 2 in brackets on the numerator and the denominator. And then you can simplify. Are there any questions about this one? Okay. All right, let's go to another one. Oh, please don't tell me you disappeared. I can write it out, I guess. There it is. Multiply. Write your answer in simplest form. Identify all NPVs. Okay. Where do we always start? Factor. Okay. So let's start here. What can you factor out of these guys? Or is there anything we can do here before even we factor? 4c squared and a 4c squared. What can you do with those? What's 4c squared plus 4c squared? 8c squared. We can collect like terms. So let's simplify that again before we factor. It's kind of silly. Can we factor anything out of this way? 3c minus 3d? What can you divide both those by? 3c minus 3d, what can you divide? 3. What are we left with? C minus d. Thank you, Jesse. Okay, c squared minus d squared. Leah, what's that? Yeah? How can we factor that? It's a difference of squares, meaning c plus d, c minus d. We square root both, and one's going to be positive, one's negative. All right, is there anything else we can factor? 8c squared plus 8cd, what can you factor out of that? 8c. Okay, what's left in the brackets? C plus d. So everything has to be in factored form before we can multiply and start simplifying. All right. Do we see lots of things that can cancel out? Lots of goodies. Kristen, what's one thing? C plus c's, thank you. Let's reduce to 1. Priscilla, what's something else? The c minus d's over here, good. Brittany, anything else? The 8's, good. Andrew, anything else? No. Okay, so what are we left with on the numerator? What's left over? 3 and a c. And what's left over on the denominator? Just 1. We could actually write that as just 3c. Okay, so here's the thing. We still have to say the restrictions before cancellation. Have we dealt with anything like that before? Not really, right? So how do we figure out restriction? We don't want set them to 0. So we're going to set each one of these to 0. So I'm going to just do that off to the side. So c plus d equals 0. I'm going to solve for one of the variables. Get it by itself. So let's get c by itself. How do we do that? Subtract what? D. So c can't be equal to, these are gone. 0 minus d is just a negative d. So c can't be equal to negative d, comma, we have to do the other one now. C minus d can't be 0. Maybe I'll put the can't equal to. So getting c by itself, c cannot equal d. Add d to both sides, so c can't also equal to d. So we can even say c can't equal plus or minus d. So if it looks weird and we have an MPV, just take that factor and set it equal to 0 and solve. Right? If you're not sure how to deal with it, set it to 0 and solve. Okay, this lesson's broken into 2 parts, and I'm not sure if I'm going to start the second part just yet. Okay, so if you grab your homework book and open up to 4.3, which is on page 98, can you circle the following? So it's kind of obvious which ones are multiplication and which ones are division. So I want you to just practice the multiplication questions first. So if you want me to tell you which ones they are, I can. So the multiplication questions are numbers 1a and c. So maybe you want to circle them, because that's today. And then the rest would be after when we do division. 2a and d, it's kind of obvious. It's the ones with the multiplication instead of division. Turn the page. 3, all of 3. A, B, C, D. None of 4. 5, A, B, C. Not 6. 7, A, B. And then number 8. Okay. Can you do me a favor for number 8? Because there's a mistake in the workbook. For number 8, when the question says 45x minus 15x squared all over 6x cubed minus 12x squared, this should be an 18, not a 12. Can you change that? The original part should be an 18. And then they go on to solve, okay? And then find the error. That's what I want. Okay? Good? It's kind of silly that an error question literally has an error. There's 2 errors actually in the problem. So I'll tell you which one, make this an 18 and then find the other error, okay? So the first step is correct, I'll tell you that much. First thing they do is correct. Okay? All right, so I'm going to start working, and then well, I'm going to see if I might start the next part. I'm not sure yet.